remember at the bottom left, that is what you see there in black is the platform. Every station has a fixed platform on which passengers alight onto the station, or freight forwarders use to load, trolleys and drive the trolleys to load cargo into the train. That is also a fixed feature. So if it is not considered in the loading or the type of carriage being used, then these fixtures or platform will be damaged each time a train that is does not operate within the loading gauge comes across. The loading line class and weight limitations are set charts given, in various networks. Under the SGMS, that is the regulation for the Far East, China, Russia, and countries. That may be different from the charts used in the what is OCTIF countries, which are regulated using the CIM. The mathematical formula for calculating the maximum weight per axle are indicated here. Is the sum total of the wagon weight. Remember, the wagon itself has weight, and when you add the payload, that is the weight of the cargo that you put into the wagon, and divide it by the number of axles on the wagon. They may be typically 2 or 4. That will give you the maximum weight per axle. So also, if you want to find out the maximum weight per meter, in rail, you can't just load cargo onto the platform just because you have space on it. It's not like road transport. See, for every meter or so, there is only, so much weight you can put on. So in rail loads, as we go on, you see that there may be space in a wagon, but it's not everywhere that you can put cargo in, depending on the weight allowed or maximum weight that is allowed for you to load. And the formula for determining the maximum weight per meter is given by the total of the weight of the wagon plus the payload, which is the cargo you put into the wagon, divided by the length over the bumpers, and that will give you that formula. So this is a mathematical thing, so there's no need wasting time on it. It's always given in for any particular network that a forwarder may want to use. Now, each country, just like Ghana, if we had our network working, each country has a standard class, but there are exceptions within countries which must be considered. For example, a rail line class in Sweden may be classified as B1. See, Netherlands may be B1, Germany C2, Great Britain B1, Turkey B2, Holland C3, France C4. All these classifications shows you that, the A is the lowest, followed by B, and C is higher than B, D is higher than C. Okay, so when you have B and B1, B1 is higher than B, B1, C1 is higher than C, C2 is higher than C1 and C, D2 is higher than D1, D4 is higher than D3. So that is how the classes, you see, it's described by the alphabet and by the numerals that follows it. A will be the lowest, the next higher class will be B, the next will be C, and the highest will be D. So class D is higher than class C, class C is higher than class B, class B is higher than class A. And then if you have, C1, C2, C3, it means C3 is higher than C2, C2 is higher than C1, so forth and so on. In fact, the maximum total weight per class for a certain wagon are indicated at each wagon so that the forwarder can elaborate the possible payload by deducting the weight, the wagon weight. Note that the forwarder must know the lowest class of the route planned. This helps you to guide because every class determines the weight that you can load in the wagons. The wagons will be the same, but If the class is higher, for instance, for a C class, you probably can load it more than you can load the same cargo into a B class. If you have a D class, you can put in more weight in the same wagon. But if the same wagon is being used in a lower class, it means the weight will be lower. And so is speed. The higher classes may allow higher speeds, the lower classes would only allow a speed up to a number. So it is important that the forwarder knows the rail line class so that you will know how fast the train will go, and that helps you to determine how quick you can deliver your cargo. So also the class would help you to know the limit of weight that you can load in a wagon. So it's the same wagon, but the class will determine how much weight. And there is a table for that, which will follow. Right. This table is what guides what the forwarder needs to do regarding the line class, the maximum weight per axle, and the maximum weight per meter. In a typical A class, the maximum load that you can put in a train, if it's a 2-axle wagon, the total weight per axle is 16 tons. So the maximum weight you can put into a 2-axle wagon for A class will be 16 tons times 2 because it's 2 axles. So the maximum will be what? 32 tons. And the maximum weight per meter is 5 tons per meter. So if the length of the wagon is only 10 meters, then for each meter, you can only put 5 tons in it. But remember, the maximum tonnage should not exceed the maximum allowed. So this is what the table does for you. I just have to help you to understand how it's used. For B1, class B1, the maximum weight per each axle is 18. So if it's 2-axled and it's B1, it means you can load up to 36 tons in a 2-axle wagon. And if you are using a 4-axle wagon, it will be 18 times 4. 18 times 4 is 72 tons. And in your spacing, you have to consider not to load beyond 5 tons for any meter. So you can only put 5 tons on weight, for just a meter length of space in the wagon. I hope you understand it. When you get to C2, it's 20 ton per axle. So when we are using a 2-axle wagons on the C2 class, it means you can load up to 40 tons, literally. And then if it's a 4-axle wagons, you can load up to 80 tons using the same wagon only on C2. And the spread of weight for C2 is 6.4 tons per meter. It means you can increase the tonnage of weight that you put on 1 meter up to 6.4. Whereas on A class, you can only load up to 5 tons. This is what the table sets out to do. In, for instance, D4, which is the highest, the maximum weight is 22.5. So if a particular wagon is being used to carry load on a D4 class, it means 2 axles will carry 50 tons and 4 axles will carry almost 80. This is about 90 tons. But remember, in any device use, you don't always apply the highest and the maximum load. You would have to allow for some differences. That is the essence of this table. It gives you the class that you are using. It helps you to know how much weight you can put in a wagon, and that is determined by the number of axles on it. So if it's 2-axle, then on each axle you can weigh up to 16 tons for A and 22 tons, 0.5 for D4. And the spacing. As we go on, you see, I'll show you a pictorial form of how a train is loaded. In wagons, you don't just put everything into any space available. No. The maximum weight per meter It guides how you load. So in loading wagons, people have to understand the people who load it can't just be any tout, but forwarders will have to train the people who load cargo. Otherwise, you get into trouble because it has to be done in the office, well calculated, and then you apply what the computations that you make in loading. Forwarding requires knowledge. Even loading cargo cannot just be done, just as we do for road transport or maritime transport. It requires trained and competent staff to work. In this chart, I'll explain to you what, the concept behind the labeling of wagons. There are inscriptions in it. In the middle part, you see that there is somewhere in boxes ABC. Under the ABC, there are certain figures. Under A, there is 39, and then under B, there's 47.0, and then under C, there is 66.0. And on the left side, there is S. Beneath it, there's another box with 21 RIB and 51 PKP, and then there's a serial number Y5.